This video was made possible by RomTek Electronics. Hey guys. So, have I got a treat for you today? I might be a bit late to the party when it comes to this particular video, but I made some friends at Tektronix and at a Romanian distributor for Tektronix, the only authorized reseller. And they were kind enough to give me something very cool to review for you guys. Now, granted, I didn't have a lot of time to spend with it, but I think I've developed a sufficiently competent impression of the thing I'm about to show you. Might have seen it from the title. So, without further ado, here it is. The 2 Series MSO. Now, this, when I first saw it, the form factor just shocked me completely. It's barely bigger than my 2 hands, so it fits in perfectly with my talking hands format. This is a demo unit, so it means it's got all the bells and whistles, all the features, everything, well, not everything. It doesn't have the logic analyzer option yet, and it doesn't have the battery. And yeah, that battery just makes it run on battery. The channels aren't isolated between each other, but they will be floating. And I don't know exactly the runtime, but anyway, this thing only draws around 60 watts, so provided it has a big-ish battery, I'm expecting a few hours of runtime. Those 60 watts should be very generously overestimated. So let me talk you through the device a bit. I'm not going to give you technical details or anything like diagonal of the screen or stuff like that. That's marketing, and you can read it, and I'll put a link in the description to who lent me this unit and to Tektronix's own website where you can read more about this. But it's about the size of a standard A4, a bit larger than a standard A4 piece of paper. It's very nice and light. It's got a vase mount on the back, which is exceptional. It's absolutely brilliant. I never thought that I was going to say that, but the vase mount is a work of genius. It's got a few USB ports and a LAN port, the logic analyzer port on one side, if it would focus. Anyway, you get the point. And on the other side, it has a somewhat poorly positioned and implemented power connector and a grounding strap. Why do I say it's a poorly implemented connector? Well, the connector is this. It has an external power brick. And first of all, it sticks out from the side of the instrument. And it's kind of hard to plug in, first of all. And the second thing is that it's not very robust. I wouldn't trust it to yank out and not destroy the connector inside if something were to happen. Now, mind you, it is actually a positively locking connector, so you pull on this jacket and it releases some pins on the side. But I would have liked at least something like a screw-mount connectors or something like that, something more solid. Now, the best idea would have been a magnetic connector, but yeah, that's hard to implement, or at least have it recessed a bit deeper inside the instrument or on the back so as not to be protruding out of the instrument like this. It's kind of disappointing. While we're on the disappointing side of things, it takes quite a while to boot, and while it's booting, it runs its fans pretty much flat out, but it's very quiet. Like, you can barely notice it running. It's so quiet, it's actually more quiet than my laptop or my desktop, and it's a very, very pleasant instrument to use. I have it like this for the moment. It actually comes with a stand I don't know if it's gonna fit entirely, but anyway, it has two angles at which it can be mounted using these VESA captive screws, and you can mount it on any shape or form of VESA mount for any display. It's got the smallest VESA configuration, and you can rigidly mount it to any desk. It doesn't take up desk space, it doesn't produce extraneous clutter, and something like that. So it's still booting, and I'm pretty sure it's running some sort of embedded Linux or something like that. I'm not allowed to take it apart. It does a power on self-test when it boots up, and I have plugged in a mouse so as not to leave my fingerprints all over the gorgeous display, but it boots up. I have ran signal path calibration SPC for it. It had a tiny bit of offset because probably my room temperature here is a bit different from others, and I let it warm up for a while. Ran signal path compensation, which can be accessed from utility calibration, and yeah. And okay, so what is this? It's a 500 megahertz scope. So you can buy them in 70 to 500 megahertz. And let's look at the license options. So this one has the ultimate bundle, which includes the AFG, the arbitrary function generator, and it also has all the hardware options for the bandwidth. So 70 to 500 megahertz update, it's got everything. And I think one of these with all the options is going to set you back about 8 grand. So it's not cheap. You are paying for the Tektronix brand a bit, but what you're mostly paying for is the form factor, which, and I'll stress this again, is absolutely delightful. I've never had such a pleasantly compact oscilloscope with so many features. It's amazing. For me, this oscilloscope is basically perfect. Because I'm doing the complement sandwich thing, let's talk a bit about other slightly disappointing aspects of the oscilloscope, and then we can do some tests and I can show you a few things what it can do, because I was generously provided with the demo board for these mixed signal oscilloscopes, and this is a Tektronix made board. It's got a couple of, I think, Infineon processors on it, and it generates some I2S, I2C, anomalous frequency, anomalous behaviors, like a frequent anomaly and a rare anomaly, RS-232, I2C, CAN, SPI. It's got a very fast pulse, a fast edge, and a noisy sine wave, but we'll talk about this a bit later. This is just to show the capabilities of the instrument. Now, these are made to, because these are made by Tektronix, they're going to show you exactly what Tektronix knows the scope is good at, which is to say that it's a bit cheating, but still, the things that this board with the scope validates are remarkable. The scope is, for a general purpose lab scope, I'll say it again, it's the best. I'm pretty sure that there's no better oscilloscope in this price bracket for a professional, competent engineer with a very small desk space. Now, you could go to Siglent's or, I don't know, Rigol or stuff like that, and you can hack those as well. But yeah, this has Tektronix's support behind it and the quality, and you know, you pay extra, but in my opinion, if I had the money to get one of these, I would totally get one of these. Right, so on the front we have not the usual Tektronix VPI, their versatile probe interface with the connectors. but regular BNCs. Disappointingly, they don't even have a probe detection thing for detecting whether a probe is ×1 or ×10 attenuation or stuff like that. I think they could have squeezed in a bit of flat flex PCB with some contacts and just spun around a couple of new kinds of probes, or at least an adapter. But if you want to plug in their active probes or their differential probes or current probes, you have to get a specific external brick that the probe plugs into, and then it plugs into this, and yeah, it's a bit of a mess. I would also have liked a 50 ohm input. The signal generator can switch from high Z to 50 ohm as you'd expect for any decent signal generator, but the input of the scopes is only limited to 1 meg ohm. Decently good capacitive loading, 14 picofarads. It's pretty good. The user interface is very nice. Like, I'm pretty sure that they've thought about it far more than I could ever think of a user interface. It's what you'd expect. One knob for position and scale for the vertical, and you have to select which channel you want to apply the setting to. Most of the encoders are push buttons as well, so the only thing that isn't, the only one that isn't is this horizontal scale, which is a bit disappointing because I would have liked, for example, to have a easy way of zooming. So if I want to zoom into a particular part of the waveform, I have to toggle the zoom on and off. And yeah, and now the cursors do different things. So they're kind of like the wave inspector on the 3000 and 4000 series, but not as elegantly implemented. If you use the scope on its stand, make sure to peel off the plastic film on the stand, because otherwise the stand will slip all the time. It actually caught me, but I didn't want to remove the foil that protects the silicone mat. It was very easy for me to move the scope by pressing the buttons. These are actually very, not very clicky. Some of them are a bit clickier than others, but they're not extremely clicky, and they're kind of hard to press. So what I imagined is that they want you to cradle the scope like this with your fingers behind it and use it sort of like a tablet, which is very nice. Like, it's a very pleasant interaction with the scope, and it feels like you're hugging it, and, you know, treat your test equipment nicely. It deserves it. Okay, so evidently 4 channels. We got an external trigger in or aux in. You can configure what this does. We have the probe compensation. There's some grounding points for the logic probes, and I think there's a thing in the menu. As I said, I don't have the logic analyzer option on this unit, but I think there's something to do with adjusting something in the logic analyzer as well. It has a touchscreen enable or disable. Funnily enough, the touchscreen, now if I touch it, it won't register a touch, but I can still use my mouse, which is nice. I think you can also put a keyboard into this thing. It helps with the callouts. So you can drag these callouts, which are basically labels, and you can edit them, and you can, for example, change the font, or say something, this is a weird glitch that's happening here, or something like that. If you right click or holding your finger on something is a right click, and you can access extra menus by right clicking or holding. It has a stacked display mode, which I really like. So it has basically, now it has 2, 3, and 4 different waveform displays, and if you can independently adjust settings for each of them, or you can have it as a traditional scope with the overlay mode. one thing that is very useful for this stacked display is, for example, if you have an FFT function, it immediately puts it in its own particular dedicated window. So you have your analog channels and your FFT here. The FFT is surprisingly nice. It's actually very decent. I think it's done in hardware. The scope does slow down a bit while the FFT is running, but it's not terrible. So, and when the FFT is enabled, the vertical and horizontal affect the FFT with when you have it selected from the bottom here. Now, if I go to this channel, it will still affect only the FFT. So I have to, configure what I want to adjust. So it's better that you just turn off the thing, set your do your settings as you want, and then enable the FFT and observe in consequence. So let's look at some signals, and let's talk a bit more about what the scope is like to use. As you can see, it's very quiet. I don't think it's meant to be operated like this, but the vents clear on both the top and the bottom, and it's been running like this for a while, and it's never gotten warm. And for reference, it's around 22.5, 23 degrees in here. So let me just grab a probe and we'll look at some signals. So first of all, these aren't the probes it comes with, of course. These are some of my old 500 megahertz probes. And they fit just fine. They're Tektronix probes. And I have done the compensation for the probe capacitance previously. That's one thing that I miss about the VPI interface. If you have a VPI probe on a 3 or 4 or 5 series scope, or even a 3000 series scope, I think it still works on a 3000, but 3, 4, 5, etc. series scopes, you put the probe in, you connect the probe to the compensation, you hit probe compensation, and it does it automatically much better than you can do with, adjusting a tiny trimmer capacitor inside and getting the nicest response from the probe you can get. So one thing that I don't really like about the interface is that the vertical and horizontal, for me at least, are switched around. So I'm really used to have the time base on the rightmost part of the scope. And that shows because every time I go to change the time base on a signal, I find myself hitting this button and then getting the clipping warning. And actually, I've adjusted the sensitivity, the vertical sensitivity. If I go and push it, it turns into a vernier, a vertical scale. And then I'm not sure it's actually a true vernier. It might just be software. So the divisions say, for example, 700 millivolts per division, but I'm not sure that there's an actual variable gain amplifier in there that changes that. So the 7000 series scope that I used to have at work did that, and it had true 1, 2, 3, 400 millivolts per division scales. But yeah, so let's do some measurements. For example, if we go to measure, there's a whole lot of measurements we can do, basically everything that you'd expect. So we have period, frequency, blah, 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 everything. And they're nicely, easily accessible. Another thing that I really like is you can decide what happens when you draw a box, and that only works with the touchscreen, disappointingly. So if I just do this, it moves it side to side. So I will have to touch it and show you what happens. So for example, if I draw a box, and just a second, horizontal, let's zero that. And if I draw a box, whoops, like this, if I get anything in there now, as it is right now, it will say that the test is failing, because I've described this box in which the waveform has no reason of being. Now, another thing that we can do with this mask test, and if we just stop it, let's do a nice demonstration, because this has been a gripe of many people, but not one of mine. So I'll just plug in this evaluation board, demonstration board, whatever you want to call it. I'll just plug it in here, and we shall look at the infrequent anomaly. So we have a rare anomaly. It's called rare, not infrequent. I apologize. So let's put a ground point somewhere around here, and a rare anomaly. So this is where I'm connecting right now. This is the rare anomaly terminal. And if we look at it, let me just clear this. And let me delete the mask test and zoom in a bit. See, I was going for the vertical again. And let's go to trigger normally, and let's... Now I get what's going on and why people were so upset with... It's never happened to me till now. So let's turn off the rest of the channels because we don't care about them. Okay. Apparently it slows down when you activate more channels. So let me put the trigger in the middle around here, and we can see that we have what they call an infrequent anomaly. Well, to me, to my eyes, it doesn't look very infrequent, but for example, if I go to more again and draw a box and draw it in here, right, and start the test, we can see that out of 56 waveforms or whatever it is, 16 have failed till now, 100 and something have passed. So this is a very nice way of doing like what Keysight was doing with their touch trigger, but a bit less elegant. And I'm sorry to say that, but it's slightly less elegant. You can't get the scope to trigger just on that portion. So you can't ignore all the rest of the signal which is behaving properly and just focus on the portion that is misleading you into like the anomaly. You can't ignore everything else and just trigger on the anomaly, which is a bit of a shame, but anyway. So this is the the infrequent anomaly. There is another frequent anomaly, which you should see that there's a lot more fading out of... Wait a second, let's reset this. So I don't know what the difference is between the frequent and the infrequent anomaly, but apparently this is failing faster now than it used to. Right, let's delete this and let's look at some other signal. All right, one of my favorite. Let's look at the fast edge, because this really kind of shows the bandwidth of the scope, and we can see that we're at 2 nanoseconds per division. I'll just measure the rise time. So we need to go to time measurements and rise time, and for channel 1 and add it, and it's 1.3 something nanoseconds. I think this is not the actual rise time of the front end, so it's not the full bandwidth of the scope, it's just the rise time of the signal on the board. And there's another single shot pulse that we can, it's at 512 megahertz, which is the bandwidth of the trigger system in the scope, and it's meant to show that the capture bandwidth of the scope is what it is. So if we put the scope into single trigger, which is into normal triggering, and hit the button on the board, I'll show you right away what's going on. We should see that one pulse, right? So there's only one of them. So what I did, and maybe you can see when I'm doing this, so I'm pushing this button, and you should see the waveform updating every time I get the pulse. I hit the pulse, I trigger it. And the pulse is reasonably long at 200 nanoseconds, but it's pretty fast, and yeah. Right, of course it does all the SPI decoding that you can want, but it actually does things a bit more interestingly. So let me put in some extra probes. Let me reframe, because in my excitement I have accidentally moved the thing a bit. And I'm really trying to not stretch myself too thin with this review and not make it take too long, because I don't want to bore people. And okay, so let's go to, I don't know, let's go to I2C. And we have clock, and channel 2 will be data. So the blue channel will be data. Right, and now if we go back to auto trigger and set these things up more reasonably. Is this the correct probe? Yep. Let me change this vertical and the horizontal settings a bit here, and let's reset the thing, and we should be able to see a I2C signal being displayed. And let me adjust the trigger a bit. Actually, let's do something even better. So if we go to the utility and hit demo and go to serial bus and hit I2C, I have to double click it. This is one of the things that I like absolutely the most about this scope. So you can see it did a whole lot of things by itself right now, and it captured a bunch of communication, and it's showing us various address read writes, the timestamp of the event, what happened, the data that was communicated, if it was acknowledged correctly or not, for example. And the coolest thing is that it logs all of these events and displays them nicely in one of these tables like this. And let me just adjust the brightness a bit so you can see better. So I think other scopes had this as well before this, but I really love it. And the funniest and the coolest thing for me is that you can go into individual transmissions, and this works for all protocols. You can go to individual packets or individual events and look at them, and the scope will show you exactly what happened on the bus and at the same time. That's really great. So it knows when the transmission started, when it ended, it decodes the data for you, it displays it in a nice bus and ASCII format or whatever you want it to be displayed as, and it shows you where an error happened or something. So this is really nice. This thing would have saved me so much heartache and trouble in the past that it's just insane. I can't believe it. It's really nice. And this is not like a built-in demo that just runs. It actually took the data from the board and analyzed the data from the board itself, which is just great. Let's take a short look, and for that I need to I'm gonna hit default setup, and I'm going to get my BNC cable here. This is actually a very long BNC cable, but I have it coiled up in a bunch. So let's take a look at the arbitrary frequency generator. So if we have a sine, show us a sine, and it's a very nice sine. The maximum amplitude for the signal generator as it stands is, if you double click this, you can say 5, none. So it goes to 5 volts peak to peak. And I need to change the probe setup to be 1 time. So 1x. This is the thing that I was complaining about. They could have at least stuck in a ring around the BNC and make it auto-identify if you've plugged in a probe or if you've plugged in just a regular BNC cable, because all of the probes that I've seen so far have this pin here which is connected to the shell of the BNC, and if they detect a short between that, it just tells the scope, look, there's a probe plugged in, change the vertical range. And we have I think it's a 50 megahertz signal generator. Let's see. 50 megahertz. Yeah. See, I'm hitting the horizontal, the vertical instead of the horizontal again. And it's a 50 megahertz, and let's go to something more reasonable, like 5 hertz. And let's go to a cardiac. I always find it funny when I see cardiac pulses, like cardiac waveforms, that you can generate up to like 100 kilohertz. I never understood why that thing is. So this is how a heart rate would look like if it came out of a robot. So this is the P, Q, R, S, T, U waves. And this is another pulse here. I don't remember if that's the W. Anyway, let's see just how fast you can crank this. So let's go to frequency, and now the context-aware A and B buttons do what you expect them to do. So 10 hertz would be my, for example, my resting heart rate, around 60 beats a minute. Let's go to 20 hertz. All right, about here. So this would be 120 beats per minute, or just about as fast as my heart started beating when Tektronix told me they were going to give me this for a review. 50 hertz is just about being completely dead. I think that 180 hertz is the heart rate of a very, very good athlete at peak exertion. So this is your heart beating at 180 times a minute. And this is way beyond dead. And let's see just how fast it can go. So this is an audible range. It's been in audible range for a long time. So 500 hertz, 3,000 times a minute. Your heart rate would be beating its ass off to go that fast. And I always find it funny, like, why would you put a heart rate signal that can go to, let's keep cranking it, and let's just make fun of this because it's very funny. 20, 30 kilohertz, 40 kilohertz, 50, 60, 70. Jesus. 80 kilohertz. Right. My point being that anybody who's designing electronics for medical and wearable devices and stuff like that and is trying to look at a heart rate will never need a heart rate going past 40 hertz. And why? Because they're also designing the filters that those analog front ends that are responsible for picking up the heart rate signal have to filter out. So if you're going past 40 hertz, first of all, the person is already dead. And second of all, you're dangerously close to the main line frequency that you're anyway going to filter out completely when you're designing an electrocardiogram or something like that. So that's about it. I'll reiterate. The most pleasant form factor of an oscilloscope I have ever seen were it not for the relatively dumb input connector and the lack of probe interface of any sort, this would have been absolutely perfect. And I'm not just saying that because I'm not getting paid for this review. I just got it for a while to screw around with, play with, get familiar with, and just review honestly. And that's why I started with the bad parts, because like it boots pretty slow, input power connector is pretty dumb. It might run a bit slower when all the channels are enabled, but they stuck a 500 megahertz 4-channel scope, 2 gig samples per second in this big of a form factor. And it's user friendly. It's fast enough. It's low noise enough. It's got wonderful capabilities. It's got a beautiful screen. Slightly dumb user interface problem for me with the vertical and horizontal being inverted. But Jesus, this is a completely remarkable achievement. And if I were a hat, my hat would go off to Tektronix for getting this to work as nicely as it does. And the thing is completely beautiful. Like, I have a few 5000 series scopes at work, the big ones, the 6, 7, 8 channel ones, especially stuff like that. And I really love their new industrial design. They're very, very pretty, but this one takes the cake. This is like a couple of inches tall and about the same size as this thing. Actually, this is my one of those LCD tablets that you write on for taking notes. So, and it's lightweight as well, so you could comfortably carry it around in a backpack. So TLDR, if you've stuck so far, thank you for watching. This is an excellent scope, if a tad pricey. Wonderful for vase amount, form factor, capabilities, performance. I wish they'd just done something with this input connector and maybe make it a bit less draggy when you do stuff with it. But it's more than acceptable enough. Like, hats off. So thank you for watching. I might be able to get more Tektronix gear to review for you guys in the future. If you'd be interested in that, consider commenting so everybody knows that this was either well or poorly received, depending on what you think of it. And who knows, maybe we can get to review something more bigger next time. So that's been all for now. Thank you for watching and have a great day. Goodbye.